All right, so what we're going to do in this lesson is we're going to learn how to identify an arc length. Now, an arc is a partial circle, okay? It is a, let's say, the distance from here over to here, or the distance from here all the way around the circle over to here, okay? An arc is a partial circle. It is a distance not quite all the way around a circle. That's what we call an arc, A-R-C, okay? Now, in order to calculate the length of an arc on a circle, basically because it's a fraction of the entire circle all the way around, the first thing you have to remember how to do, something we have to review, is you have to be able to calculate the circumference of the circle. The circumference of the circle is the distance all the way around the circle, the full distance all the way around the circle. And the formula for circumference is circumference of any circle is equal to 2 pi times r. Now I want to remind you what pi is. Pi is radians. It is the distance halfway around the circle. Okay? If you were to take the radius of a circle and use that as a measuring stick, you would get pi radians if you went halfway around. Well, if you go the whole way around, it's 1 pi, 2 pi. That's why we have 2 pi. And then all you have to do is take the 2 pi and multiply it by the length of your measuring stick, which is the radius. Okay? So you give me any radius, and all you have to do is multiply that radius times 2 and put a pi on it, and that is the circumference. Okay, so in this lesson, we're not gonna hit times pi in the calculator, and we're not gonna multiply by 3.14. All of your answers are simply going to be the radius times 2 with a pi sitting next to it in the answer. Okay, so very simple here. If we said that this was a circle that had a radius of 7, actually that's sort of ugly there because you're looking at it sideways. Let's just make it a better looking 7. 7. Okay, if the radius is 7, then the circumference of this circle is going to be 2 pi times 7. 2 times 7 is 14, so the circumference is 14 pi. If the radius is 11, then it's just 2 pi times 11. 2 times 11 is 22 pi. So the circumference of this circle is 22 pi. So all you have to do is double the radius and then put a pi on it, and that's the circumference. Well, we shouldn't have to write that down, right? Here, I'm going to draw a new radius, maybe from here to here. Okay, so let's say that the radius is 14. Well, 14 times 2 is 28, so the circumference is 28 pi. If the circumference is 19, if the radius is 19, then the circumference, double 19 is 38, is 38 pi. And now the last one we're going to do is this. What happens if the radius is 1? What if it's a circle that has a radius of 1? Well, that's even easier because the formula is 2 pi times r, 2 pi times 1, well, anything times itself is itself. So the circumference of a circle that has a radius of 1 is just 2 pi, okay? Just reviewing how to calculate the circumference of a circle. All right, now we're going to take the review of calculating the circumference, and we're going to move into calculating arc length. Now, you have probably done this before, but it was probably a long time ago, and I want to do it with a very specific focus. So here's what I've done is I've broken up the circle into 8 equal sectors. A sector is like a slice of pizza in a circle, okay? This kind of almost triangle-ish looking shape that's curved along the outside, that's called a sector. And what I've done here is this, is I've, through the center, I've cut it in half this way, then I've cut it in half this way, then I've cut it in half this way, and I've cut it in half this way. The result is 1, 2, 3, 4, 5, 6, 7, 8 equal sectors. And so if I were to choose, let's say, 1, 2, 3 sectors, just 3 of the sectors, that would be 3/8. That would be 3/8 of the circle, okay? Now, you could say that the area of these 3 sectors would be the area of 3/8 of the circle, but we are not dealing in area in this lesson. We are only dealing in distance, okay? What I care about here is this. If I chose 3/8, this one, and this one, what I would be concerned about is the distance along the outside of the circle, starting here and going around to here. And my question would be, what is the length of this arc from here to here? Now, the reason I broke it up into 8 equal sections is because it's going to make it easier for us to take a fraction of the circumference. See, the circumference is the whole way around, right? But if we go from here to here, we're only doing 3/8 of the circumference, okay? And so the way that we would then calculate the arc length is very simple. Step 1, the first thing you would want to do is calculate the circumference. And then step 2, identify the arc fraction. Okay, so how many of the slices out of 8 slices? Identify the arc fraction. Step 3, multiply the circumference from step 1 times the fraction in step 2. And then step 4, reduce the fraction if possible. And if you do that, you will then have the arc length of that particular arc. Okay? So, for example, now in order to be able to calculate the circumference, we are going to need to know the radius of this circle. So let's say this particular circle has a radius, let's say it's got a radius of 8. So this circle has a radius of 8, and we want to know the arc length from here all the way around to here. So to know the arc length from here around to here of a circle that has a radius of 8, here's what we're going to do. First, we're going to calculate the circumference. Well, if the radius is 8, we know that we just need to double the radius, right? So 8 becomes 16, and then put a pi on it, right? So circumference is equal to 16 pi, okay? Now we're going to identify the arc fraction. Okay, well, we've got 1 sector, 2 sectors, 3 sectors out of 1, 2, 3, 4, 5, 6, 7, 8. So step 2, we know that it's 3/8 of the circumference. So that means now all we have to do is multiply 16 pi times 3/8. Okay, well, 3/8 times 16 pi. Now, you may not know this, but this 16 pi, technically it is a fraction. It's 16 pi over 1. So we're going to multiply the numerators. 3 times 16 is 48 pi over 8 times 1 is 8. And then step 4, reduce the fraction. Well, 8 divides into 48, okay? 8 goes into 48 6 times, and therefore our final answer is 6 pi. And that is our answer. So the distance, the length of the arc, starting here and going around to here is 6 pi, okay? Now we're going to do a few more examples, and I want you to try them. All right, I want you to try this one. We've got a circle that has a radius of 11, and we're starting here. We want to know the arc length starting here and going around to right here. You see that blue line? We want the arc, oh, I'm sorry, I didn't go quite far enough. I meant to go to this line right here, sorry. There we go. All right. So I want the arc length from here around to here of this circle that has a radius of 11. Pause the video, calculate, and then I'll do it. Okay, so first thing we're going to do is we're going to calculate the circumference. Well, we know that the circumference of a circle is double the radius, so 11 becomes 22 with a pi on it, right? So the circumference of this circle is 22 pi. And now we got to identify the arc fraction. Well, starting here, we have one sector, 2, 3, 4, 5 out of 8 total. So 5/8 of the circle. So 5/8 of the circle. And now we're going to multiply 22 pi times 5/8. So 22 pi times 5/8. Basically what you're doing is you're just going to take this 22 pi and multiply it by 5. Because if this was a fraction, it will be over 1, and 1 times 8 is 8. Okay? So we know that this is going to be over 8. And 22 times 5, well, that's 110. So we have 110 pi over 8. Now we're going to reduce the fraction if possible. We can reduce it. I know that 110 and 8 are both divisible by 2. Okay? So 110 divided by 2 is 55 with a pi over 8 divided by 2 is 4. And so our final answer is this arc length right here is 55 pi over 4 units. Whatever the radius units is, that's what the units for that particular measure is. Okay? All right, let's try another one. All right, here's another one. Now, before you start, let me just say something. Do you notice, so here's our third example. Do you notice that in every one of these examples, I always start the arc right here? I always start here. And if you remember from the previous video where I explained pi, I started here also. I'm doing that on purpose. In this class, and probably this class only, for us, all of the arc lengths are going to start here. If you're just in a regular geometry class, you can have the arc start anywhere and go to anywhere. But we're in pre-calculus, and I have a very good reason, a very specific idea that we're moving towards that requires me to start here. We have to remember this point in what we're learning right now, which is trigonometry. We're always going to start at this point right here. Okay, so for this particular problem, I want you to identify the arc length of from here up to here along the outside of the circle, okay, on a circle that has a radius of 5. Okay, pause the video, go. Okay, so first thing we're going to do is calculate the circumference. Circumference of a circle that has a radius of 5, we're going to double 5, so that becomes 10 with a pi on it, right? So the circumference of this circle is 10 pi. And then now we need to know how many of our sectors out of 8. 1, 2, 3, 4, 5, 6, 7, 8. Out of 8, we're addressing 1, 2 sectors. So 2 out of 8. 2/8. Now, if you'd like to, you can reduce this 2/8 to 1/4 before we move on. That's fine. Or you can leave it as 2/8 for now. Step 3, multiply both of these numbers. So we're going to multiply 10 pi times 2/8. All right, so we're going to do 2/8 times 10 pi. If we multiply those, 2 times 10 pi is 20 pi. And now we're just going to carry over the 8. And so we have 20 pi over 8. Now, we need to now reduce this fraction. 20 and 8 are both divisible by 4. So 20 divided by 4 is 5. So 5 pi over 8 divided by 4 is 2. And so therefore, the arc length from here all the way up to here, the arc length is 5 pi over 2. Okay? Let's just do one more example, and then we're going to do some more arc lengths, but with a new circumstance. All right, why don't you try this one? Just pause the video, calculate the arc length. All right, this one should be pretty simple. We want to calculate the circumference of a circle that has a radius of 3. Double the radius, 3 becomes 6, put a pi on it. So the circumference is 6 pi. Identify the arc fraction. Okay, out of 8, we have 1, 2, 3, 4, 5, 6, 7. So it is 7/8 of the circle, or 7/8 of the circumference. So now we're just going to multiply 7/8 times 6 pi. 7/8 of the circumference is equal to, well, 6 times 7, that's 42 pi over 8. 42 and 8 are both divisible by 2, and therefore we can reduce this to 21 pi. 42 divided by 2 is 21, and 8 divided by 2 is 4, and therefore the arc length from here around to here in a circle with a radius of 3 is 21 pi over 4. And I know you're thinking you really, really want to key this into the calculator. You really want to do 21 times pi and then hit divided by 4 to get just a number. Not this time. We don't want to know the precise decimal calculator number. We are going to be working in fractions that have pi in the numerator. That is important for us. Now we're going to move on to, we're going to continue doing arc length, but I'm going to change the number of sectors. Instead of having 8, we're now going to go to 12 sectors. All right, what we're now going to do is, we're going to continue doing the exact same thing, but instead of doing them out of 8, we're now going to break up our circle into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sectors. Okay? And so now when we try to identify arc length, we're only going to go to these dots. And when we identify our arc fraction, it'll be out of 12. Okay? So let's say that we have a circle that has a radius of 7. Radius of 7. And we want to identify the arc length from here over to here. Okay? Well, we're going to do it the exact same way. We're going to follow this exact same procedure. We are going to first calculate the circumference. Well, if the radius is 7, double the radius becomes 14 with a pi on it, right? So the circumference of this circle is 14 pi. Now we're going to identify the arc fraction. It's going to be out of 12. So we've got 1, 2, 3, 4 units, 4 slices out of 12. So that's going to be 4 out of 12. Now, you can leave it as 4 out of 12, or you can reduce this to 1/3, okay? Because we know that 12 and 4 are both divisible by 4, so this would become 1/3. Now, let's go ahead and leave it as 4 over 12 in case you're the kind of person who's not going to reduce it first. So we're going to multiply 4/12, or hang on, let's come down here. We're going to do 4/12 times 14 pi. All right, maybe you're not sure. We're going to do 4 times 14. Maybe you need a calculator, but 4 times 14 is going to be 56. So we have 56 pi over 12. Now, here's the interesting thing. We can now reduce this, and 56 and 12 are both reducible by 4, okay? So let's do 56 divided by 4, which we actually just had, which is 14. So we're going to have 14 pi. And then 12 divided by 4 is 3. And so our answer here, the distance from here around to this point, this arc length is going to be 14 pi over 3. We're going to leave it just like that, as a fraction that has a pi in the numerator. Let's try just a couple more examples. All right, why don't you try this one? We've got a circle that has a radius of 13, and we want to know the length of the arc that starts here and goes around to right here, okay? Why don't you pause the video and try this one. Okay, so we're going to need to identify the circumference of this circle. Well, we know that all we have to do is double the radius, so 26, and put a pi on it, right? So circumference is equal to 26 pi. And now the arc of the fraction, we know that it's going to be out of 12. So we've got 1, 2, 3, 4, 5, 6, 7. So it's 7 slices out of 12 slices total. So that's 7/12. 7 over 12. And now we're going to multiply 26 pi times 7/12. So 26 pi times 7/12. So we know that it's going to have 12 in the denominator. The numerator, 26 times 7, let's see, we got 140 and 42, so that's 182 pi over 12. Now we have to reduce the fraction. Now you might say, I can't reduce this, that's a really big number, and I'm not sure what goes into 12 and what goes into 182. Well, if you want to, you can use a calculator to do that. And the first thing I notice is that 182 and 12 are both even numbers. So I know that I can divide both of them by 2. So let's reduce it by 2 and then see if we can reduce it anymore. Well, we know 12 divided by 2 is 6, and 182 divided by 2, well, that's 91. So we've got 91 pi over 6. Now, there aren't any numbers that go into 91 and 6 other than 1. And therefore, this is fully reduced. And the distance of the arc starting here, going all the way around to here, is 91 pi over 6. All right, last example for this particular one. We've got a circle that has a radius of 1. And we want to know the arc length that starts here and goes all the way around to here. Give it a shot. All right, so first thing I need is the circumference. Well, double the radius. Radius is 1, double is 2. So the circumference is 2 pi. Okay? And now we need the arc fraction. Well, we know it's out of 12, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 12. And so we're doing 11 twelfths of the entire circle. That's the arc length. It's almost the whole circle, but not the whole circle. Now we're going to multiply the circumference, 2 pi, times 11 twelfths. 2 pi times 11, that's going to be 22 pi over 12. 22 and 12 can both be divided by 2. So 22 divided by 2 is 11 with a pi, so 11 pi. Oops, sorry about that. And then 12 divided by 2 is 6, and therefore the distance from here all the way around to here is 11 pi over 6. Okay? All right, so now what we're going to do is we're going to take this knowledge that we have of how to calculate arc length, and we're going to move on and we're going to use this information to calculate radians as an angle measure.